All right, guys, are there any questions on any of the assignments thus far? Any questions on homework assignments 10.1 to 10.3? If there's no questions on those there, we're going to go on and start the assignment or the notes for today. So what we're looking at today is inscribed angles and interpreted arcs. An inscribed angle is an angle whose vertex is on the circle. An inscribed angle is an angle whose vertex is on the circle. And the interpreted arc is the arc that that angle makes up. And those are the two key things that we're going to be looking at today. Now, a key property with this is that the inscribed angle, here, angle ADB, is equal to half the measure of its interpreted arc. Or the interpreted arc is equal to twice the measure of its inscribed angle. So if we said that this arc is 140 degrees, what's the measure of the angle going to be? Half of 140, which is 70. Or we can multiply the inscribed angle by 2. And that's it. So if we look at this first problem here, the first thing we want to find is the measure of angle T. So this right here is angle T. Now the arc, its interpreted arc is 48 degrees. So what do we need to do to find the measure of angle T? We can divide 48 by 2 or multiply it by 1/2. So the measure of angle T is?
I have a question.
Yes.
So, like the sunrise looking thing, that would be QR.
Mm-hmm.
So it's like asking for the angle, or not the angle, the arc.
QT. Mm-hmm. QR. So QR is this here. So we know that this is 48 degrees, yes? So we want the measure of QR. We know that this here is what? 100. Now we know the whole circle is what? 360, but we're just missing one part. 2 parts. But we still need ST. But I know from T to S to R is what? Because it's half. T, R is the diameter, yes? So we know that this is 180. Well, technically, what is this? 180. Because we multiplied it by 2 to get to 100, and because this is half, we can do 180 minus 100, which gives us 80. So again, it's just using these formulas to find the different parts. Any questions on this here? So the first thing we want to find is arc DG. Since the inscribed angle is 40, we multiply it by 2. So 40 times 2 is, so the measure of arc DG is 80. So DE would be 100, yes. Because EG is the diameter. It's half the circle. So the other part's asking for angle G. So just wanting this angle here. Because the inscribed angle is half the measure of its arc. So the arc is what? So we can multiply it by 1/2 or divide 58 by 2. Yes. because the measure of the inscribed angle is equal to half the measure of its arc. Or the arc is equal to twice the measure of the inscribed angle. Any questions on this here so far? Okay. Let's look at this next one here. So we want to find the measure of arc RS and the measure of angle STR. Let's find the measure of arc RS or SR first. What would we do?
Hey, I have a question.
Yes.
So, inside that triangle, right?
Yes. Because? Sharing a common, because what is RS? It's an, anybody? What is RS? It's an arc, yes? Now, if we work this through, and we'll see this, 31 is the inscribed angle for arc RS, yes? So to get to it, we would take 31 and do what to it? We take 31 times 2, which is 62. So that's the measure of the arc. Now, the other one it asked for was STR. So its arc is 62, yes? So they are the same, yes? So that's what's interesting about this is that these two angles, STR and RUS, are the same angle, yes? Let's look at the next formula, or next theorem. TU? Well, its inscribed angle would be these two here. So if we knew what TSU was, it would be the same as TRU. It could be 62, but not necessarily. Now the key with this here is that two inscribed angles of a circle intercept the same arc. If two inscribed angles have the same arc, then those two angles are the same. So here, GEH and GFH share the same arc. So what do we know about angle E and angle F? E and F are going to be congruent. Because they share the same arc. Because GH, since angle E is 75, it means the measure of GH, arc GH is GFH is an inscribed angle for that arc, so it's half the measure, which means this is, so the measure of angle F is 75 degrees. Questions on this here? So here they tell us the measure of angle C is 68 degrees. We want to find the measure of angle B, which is going to be 68 degrees, because since C and angle B share the same arc, they are going to be the same angle. Questions on this here? Are you ready for the next one? Okay, so this is kind of using what we just had. So we want to find here the measure of angle G. So what do we need to do to find the measure of angle G? Divide 90 by 2, because the inscribed angle, here the angles on the circle, is half the measure of its arc. And 90 divided by 2 is 45. Now the measure of arc TV What do we need to do to find it? We need to multiply because the inscribed angle our arc is equal to twice the inscribed angle. So we're doing 2 times 38, which is 76 degrees. And the last one, the measure of angle X would be 72. Since the two inscribed angles share the same arc, they're going to have the same measure. They're going to have the same degree measure. Questions on this here? All right. Our next term, inscribed polygon. A polygon is inscribed when all of its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. So we call a figure that has all the vertices on a circle is an inscribed polygon. Now specifically, we can talk about an inscribed right triangle. An inscribed right triangle is a triangle whose hypotenuse, whose one side is the diameter. Well, let's see here. If this is the diameter, we know that A to C, this red is 180. It's half the circle, yes? And an inscribed angle is half the measure of its arc. So half of 180 is 90. So this angle here has to be 90. If we inscribe a triangle inside of a circle, and one of the sides of the hypotenuse, this one angle has to be 90. And the other two are going to add up to be 90, or all three angles in a triangle always add together to be almost, for a triangle, 180. So these three angles here are going to have to add together to be 180. The whole circle would be 360. Questions on this here so far? Guys. So with the rest of these here, we're finding the value of the variable. So here, what do we know about 2x? What does this angle have to be? 90. Because we have an inscribed triangle, and this here is the diameter. So this here has to be 180, which means our inscribed angle 2x has to be 90. But that's what x would be, yes. Because we can say that 2x is equal to 90. To solve for the value of x, we would divide both sides by 2, telling us x is equal to 45 degrees. Or just 45. Questions on this here? Let's look at the next one. What do we know about 5x? It has to be 90, because again, it's half of the inscribed angle. It's half of 180, so it has to be 90. So here we can divide both sides by. And x is equal to 16. Questions on this here? Well, this one here, we have two variables. We have to solve for the value of x and the value of y. So we can do this one at a time, because we know what one of these variables has to be. Which one? X. Because really, no matter what they put for this one here, it has to be 90. Because they could put 3x, but we know that it has to be 90. So that's kind of helpful. Because now we know that this is what do we also know about, exactly, any three angles in a triangle have to add together to be 180. So we could say y plus 90 plus 40 is equal to 180. Or what are we going to do? We're going to add 90 and 40 together, which is 130, and then subtract 130 from 180, which gives us 50. Not anything really new, it's just we're doing it on a circle instead of just normal triangle. Any questions on this one here? So, we know that the measure of angle E, whatever it is half of this arc here, yes? But that's what we've been saying. An inscribed angle is equal to half the measure of the arc. Angle G is equal to half the measure of this arc, yes? So if I took angle E, its measure, and added it to angle G, well, that would be adding the green and blue arcs together, yes? And we would be taking half of whatever it is, yes? Because it's the inscribed angle is equal to half the measure of the arc. Well, what do we get when we put the green and blue arcs together? What would that be? 360, it's the whole circle. And what's half of 360? So the opposite angles in an inscribed quadrilateral add up to be 180.
Hey, what would happen if you get some color and those colors?
You would get the, I think that's secondary colors. Or not secondary, that'd be third. Or yeah, so that would be secondary because two primaries make a secondary. A secondary and a primary make a third, whatever that, I can't remember what that's called. So let's look at these here. So we look at this first one here. What do we know about y and 120? They're going to add together to be 180 because the opposite angles in a inscribed quadrilateral are supplementary. So what do we need to do to solve for y? We need to 120 from both sides, which would tell us that y is 180 minus 120 is 60. What do we know about z and 80? They add together to be 180 because the opposite angles in an inscribed quadrilateral add together to be 180. And here we would subtract 80, which will tell us that z is 100. Because the opposite angles in a inscribed quadrilateral add together to be 180. Any questions on this here? Okay. Okay, so we want to find the value of a and b. What do we know about 3a and 111? Yes. 3a plus 111 add together to be 180 because the opposite angles in an inscribed quadrilateral add together to be 180. So what can we do first to solve for a? We could, but it's going to be easier to subtract 111 first. Because if we divide by 3 first, we have to divide everything by 3. So we'll have to divide the 3a, 111, and 180, which would work, but it's nicer if we subtract first. Nope, 69. And then we would.
Wouldn't that just be like long
For synthetic or
basic
division.
algebra?
Yep. What would you need to do to solve for b? b plus
Plus 65 equals
180. Then we would subtract 65 from both sides to get b by itself. And b would be 115. That's it. Any questions on any of this here? Let's look at one last one. Let's not look at that one. Let's look at this one. I want to look at this one because here we do have an inscribed quadrilateral, but unlike all the other ones, all 4 angles have variables. So what do we know about 10x and 8x? They still add up to be 180. Because the opposite angles in an inscribed quadrilateral still add to be 180. Exactly. 10x plus 8x is 18x. Divide both sides by 18. Exactly, x is 10. What about the other one? So we would do c plus 2c minus 6 is equal to 180, and I believe we should get 62. You can get minus 6 is equal to, and then we would do what?
plus 6 on both sides, and you get 186. You get 3c minus
3 goes into 18 how many times? 3 goes into 18 how many times?
6.
How many times does it go into 6? So C is. That's it. Any questions on any of this here? And that is it. That's all we're doing for today.